All right, good morning, Y group. Hopefully my head's not too big here. This is my first time trying this, but what I'm going to be doing is just kind of giving you what we would have talked about in class, but it's just going to be on this video here. So just bear with me. Again, hopefully my head's not too big. All right, so the past few class periods, we have been trying to understand atoms. But maybe I think we should take a step back. The reason it's important that we start understanding atoms is because the world around us is made up of all kinds of physical things. Whether we're talking about our hair, whether we're talking about the air that we breathe, the water that we drink, the stuff that our buildings are made up of. Our whole world is made up of all this physical stuff, and that physical stuff is something called matter. Now the scientific technical definition of what matter is right here. Matter is anything that has mass or takes up space. Now you've got your notes, so what I would do right now is write down the definition of matter, and I will get this a little bit closer so you can see it. So again, matter is anything that has mass or takes up space. So that means anything that takes up space, and anything, any kind of object that you're going to think of is going to be made up of matter. Yeah, so just take some time and write this definition down. You can also pause the video if you need to, if this isn't enough time for you to write down the definition. Okay, let's get situated here. I hope I'm not making anyone sick. Oh boy, I almost killed the camera. All right. Yeah, this is difficult. Okay. Please don't die. All right, wonderful. Okay. So, now that we've said that the whole universe is made up of matter, we have to think like a scientist, and we have to say, well, what does that mean matter is made up of? So, we know everything around us is made up of matter. So what is matter made up of? And the answer for that, and you guys have a fill in the blank here, is elements. Elements is what all this matter is made up of. My skin and your skin is all made up of several different elements. The big ones involved would be carbon, hydrogen, oxygen, nitrogen. There's a ton of other ones though. There's probably another 30 or so elements that you'll find in a living thing. But anyways, your blank right here would be elements. And if you don't know how to spell it, it's right there. Right now we are going to say what the scientific definition of an element is. We know that it's that building block of matter. So our scientific definition of an element is the simplest pure substance, and it cannot be broken into any other substance. So let's take a look at this again. Take some time to write it. Elements are the simplest pure substance, and they cannot be broken into any other substance. So if we kept taking a piece of wood and kept trying to purify it and find out what those simplest things are that make up the wood, we would be breaking it into its different elements. So again, you can pause it if this isn't enough time for you to write it down. Right? Wonderful. Hopefully. All right, good. Okay, so the thing is we don't always find these elements by themselves. We don't see a big pile of carbon and then a big pile of oxygen. The way that we tend to find these elements is oftentimes grouped together. So we have two different ways that we can group our elements. We have something called compounds and something called mixtures. Compounds, the two elements, or the three, or the however many elements it is, they are actually chemically combined. And when they're chemically combined, they take on different properties. The perfect example for a compound would be water. And you guys probably know that the chemical formula for water is H2O, which means that you've got two H's, or two hydrogens, for every one O, or oxygen. And hydrogen by itself is a flammable gas. And oxygen, pure oxygen, can also be flammable. So I always think it's really funny that when you combine these two flammable gases, you end up getting water, which is a liquid, and obviously water is not flammable. So when you have a compound, they take on different properties because they're chemically combined. In mixtures, you tend to see just any two substances, or it can be more than two, but it could be elements together, it could be compounds, but you get all these different things mixed together and they're not chemically combined. So something like, you know, a salad is a mixture. You can see the different pieces in it. It's made up of different substances. Let's see, what else would be? Wood would be a mixture. Most things that you encounter probably are going to be mixtures. The pure substances, well, it takes a little bit more to keep them as pure. Water is a compound, and that's a pure compound. But a lot of this stuff is mostly mixtures. So here are the definitions for those two. Compounds, two or more elements chemically combined. And a mixture, two or more elements or compounds in the same area but not chemically combined. So close your eyes for a second if moving the camera grosses you out. So here we are, compounds. Two or more elements chemically combined. A mixture, two or more elements or compounds in the same area but not chemically combined. Again, you're probably going to need to press pause to be able to write this down, and that's totally okay. All right. Oh boy. Okay. That's good. All right. I hope I'm still in the picture, but if I'm not, that's totally fine too. So we now know that matter, all of this stuff, all the stuff around us is made up of matter, and we now know that matter is made up of elements, and we do know now that elements might not always be by themselves, but sometimes they get combined with compounds or mixtures. So now what we have is, what is it that actually makes up elements? And scientists didn't really start thinking about this until, like, 2,000 years ago. Around 2,000 years ago, we have this guy named Democritus, and he was a philosopher, so he wasn't really even a scientist. He was just somebody who likes to think about deep questions and think about the meaning behind things. And so what he was thinking about was all this stuff here. How small does it really get? If we keep cutting it, at what point does it stop being this stuff? So he proposed this idea of an atom. And he thought that an atom, the way that he kind of explained an atom, was just as something that you can't divide it up anymore without it, like, just not being there. So he said, all right, you can divide and divide and divide and divide and divide and divide, but at some point you can't cut it in half anymore. And that, when you can't cut it in half anymore, and I mean, he was thinking even beyond what you could physically cut, when it can't be broken down anymore, that's an atom. And it just means kind of indivisible. Okay, so we have Democritus who does this, a little bit in the 80s, like in 100 AD or something like that. So people kind of forget about that for a while. And then it takes until about the 1800s until people start thinking about